Hi everyone, my name is Johnny. I work as a solution architect at Red Hat, and today I thought that I'd do some demoing of image mode for Red Hat Enterprise Linux, or also known as bootable containers. So to get started, what I would do is that I would go to Google or other favorite search engine and search for image mode for L. And one of the first links should be a landing page where we go through or share some information and more links around image mode for Red Hat Enterprise Linux. And where I would go is to go to the blog post, which was written by Ben Briard, which kind of like is a quick start guide to get you up and running with bootable containers. So what are really bootable containers? And hopefully, as I demo things, things will become a bit more clear. But think of it as treating rel as an image and using container tooling to describe, configure, and deploy the operating system, whether or not that is to a virtual machine or a physical machine. So with that said, let's see if we can get started. So I'm in a directory here, and so there's a couple of files here, and let's forget about the other stuff here for now, and just focus on the specific container file here. So let's look at that. I'll just do this. So as you can see, this is pretty much a normal container file or a Docker file. So we have the from line, which references a base image. And then we have a run command, which is using DNF to install software inside of the container. Nothing strange about this one, right? But some things might stand out. So I'm also installing the QEMU guest agent, which is the agent for an operating system to be able to integrate towards the hypervisor to share information and things like that. I'm also installing Cloud Init and Insights Client, which might not be tools that you would install into a container. The next step is running systemctl, which you might also not be used to when we're running containers. So we're enabling a couple of services here, so like the guest agent, HTTPD, and Cloud Init, and things like that. Finally, we're just doing a very simple web page, so just to be able to display some text on the web page. And then the second piece, or the last piece here, is really, it's a minor detail. So by default, these bootable containers, they will have a timer that will automatically check in the registry for a new version of the container which was deployed from. And by default, that's a couple of hours, the default timer. So for demo purposes, I've added an override which reduces the time it takes for this timer to trigger to check for a new version of the image. So let's see if we can build this one. So nothing strange here. It goes quite quickly because I've done it before. And if I run this, let's see here. As you can see here, I'm running podman run, removing the container after it's done. I'm detaching, I'm giving it the name. I'm doing a port redirect from port 80 inside of the container to port 8080 on my system. And I'm referencing the image I forgot to push. So let's push that first. Should be quite quick as well because it's already there. And then let's see if we can run this like that. And I was having it running already. And there we go. It should be up and running. And let's go to the browser again to check our local host. And we see that the web page is running. And just to make sure that I'm not fooling you, so let's stop the container again. And now you see that the container is no longer running. So this is pretty much a normal container. The difference is that we're running systemd inside of it, so it's starting a lot of different services. But we're still just using a normal container. So how would we get this to a running system? And there's a couple of ways to do that, and I will go through three of these. So one version is to convert this container into a QCOW or a AMI or whatever image you need for your particular hypervisor. And I've already done that because that steps takes a bit. So if you look into my directory here, you see there's a QCOW directory. And there is a disk image. And I just ran that a while back here. So it's a pretty fresh one, if you will. The other way is to kickstart an image. So here I have something called rel kickstart. And basically the kickstart has learned a new trick, OS tree container. And this will download the image that I just push onto the node and apply that locally. So let's see how that looks like. So this one is the command. It's quite long, but it's giving it the name imrel02, giving it some memory and CPU, referencing a rel boot ISO, and then injecting the rel kickstart file into the initrd, and then just passing some command lines into the kernel. So when I'm doing that, I should be seeing image rel firing up. And this is now going to run in Anaconda, so in using the kickstart command. While that is running, let's also try to deploy a machine from the image that I generated. So let's copy that into downloads directory and then vert install again. And now I'm referencing the disk in my downloads directory, and I'm also injecting a cloud init file just to show you how that can work as well. And this one is called imrel01. So I should now be having two machines that is deploying. So let's take a look at the first one that I did, the kickstart file. And here we can see that it's actually running that command, deployment starting quay.io j westerl lamp boot c latest. We can actually resize this so we can see it a bit bigger. And then the second one was basically the one that I deployed from an image. And this is also slowly coming up and running. So let's see here. The cool thing about this is that these are just normal. When we create a container image, it is just a normal container image. So if you saw, I pushed it into Quay. So if you go here, you can actually see the container image. And it's a, just a normal container image. Even scans will work. So if there's CVEs inside of the container, it will actually show up here in the scan. So the normal container tooling actually works. The difference is the step where we convert this into a runnable machine, which is basically what is happening here. So this is running, and let's see if we can log into the system. So I can log in, and now there's a new command inside of this that will see reference where the container or the machine deploy the container from. So you can see again here on the image it says quay.io j westerl lamp boot c latest. So we now have a running system which was built from that container, hence a bootable container. And if you can see here on the other side of the Anaconda, we're also seeing here that it's almost done, and this machine will now power off, and I will just make sure to power it on again. So as you can see, it's when it's rebooting, you can actually see quickly there that it's referencing a deployment which is using the RPM OS tree for a boot device, and that's the image part of this system. So now we have two machines up and running that are deployed from a container image, and they are basically now checking for if there's an update to these machines. So let's log in again, and I will show you the timer real quickly. So if we do systemctl status bootc fetch and timer, you will see here that it will trigger a new run of this service in 1 minute 32 seconds. So let's see if we can actually create an update to this container. So container file, let's do a simple change. So add message of the day, run echo cool stuff to etc mltd, and then let's build, and finally push. So we're now making an update to the image and pushing it to our registry, and our machines that are running the timer should, when they see that this is being picked up, so in 39 seconds on this machine, and let's see on this one, in 16 seconds. So these should in any second now start applying this. So let's see if I can make it. It should probably be quite quickly. So let's follow that. And you can see here that it's actually applying the update. So layers already present, 70, layers needed 175 bytes. So it's quite efficient in the amount of data it needs to download, because it was only the message of the day layer that switched. And now we can see it's already booting into the new image. And we should be able to see in a sec here that cool stuff actually happened on this machine, and hopefully started apply bootsy updates. This one should probably also soon be done. And I didn't get to see it because it rebooted, and this one is now coming up again. But the cool thing is that we can actually get this to run anywhere. So I'm now running on my local machine, but what if we had a different environment where we wanted to do that? So I also have Openshift Container Virtualization in an environment. So I'll just show that real quickly. So this is an internal environment, and what I can do, there is something called a data volume. So we're using some tooling where we can actually import disk images. So what I've done is that I've created now a container disk. So this is the disk, which is basically it's just a way to copy a QCOW inside of a container to use it more as a transport. So if I just do disk container, so I'm building this one. And again, the only thing that it's doing is that it's copying the QCOW image inside of the container so that we can use that as a pushing mechanism. And then we just push that into the container registry just like we did before. And then we can reference this container when we deploy it into other environments. So I've already done that, and just to give you an idea of how this can look, let me just show you how we can deploy this image into our container native virtualization environment as well. So that actually took a while. There we go. Okay. So I will be needing to entering a toolbox because I'm on Silverblue, and I'm going to run some Ansible commands. So the first we'll do is to deploy a data volume, and just so you can get what that looks like, it's basically just a kubecrd, an object that references the same container that we built and pushed. So let's apply that to our environment. And it will take a while, but just to see that this is now spinning up, we will see a pod. It's pending, and now it's creating. So what happens is that this CRD will basically create a pod which has a data importer. So this pod will download the container, which is running in or stored in Quay or Key, and it will download it to the running cluster, and then it will import that disk image and create a bootable volume from it. So let's just inspect the logs, and we can see here that it's downloading what I mentioned before, right? The Quay image, Docker, Quay IO, jwesterl, bootc. And then it's just copying the disk file. That, like I mentioned, we just added this disk file into the container. So just using the container as a delivery mechanism of fetching the disk into this cluster. And then it's going to work on basically converting this disk image. So it's going to extract the disk inside of the container, and then it's going to convert this into a bootable volume on the system. So yeah, we will be able to reference this when we want to deploy our next virtual machine. And what we can do is I also have a playbook for deploying an instance, and I'll just show you the YAML real quickly. So it's basically just a playbook that applies a virtual machine cluster instance type, and I'll show you that template. It's very simple. And then it's just waiting for the virtual machine to become ready, and then wait for the virtual machine IP to be populated, creating a service and a route, and then hopefully it will be ready to serve request to our web page. So if we look at the template, This is basically how the Kubernetes object looks. So referencing a type, u at medium, which basically describes the amount of resources. And this is the bootable volume. And yeah, it's not very complicated things. Let's see here. So let's see if it's first done. We should be able to see under storage that we now have an IMRL data volume. And now let's see if we can create a virtual machine. Ha! Says CentOS here. That's not true. It's rel. It's a bootable container. I forgot to update the text. And the virtual machine became ready. And it's cloning. And let's see if we can see a virtual machine here. And we should see provisioning. It's working. And now it's starting. So this is some Inception style here, right? We built a bootable container using normal container tools. Then we converted it into a disk image, and we pushed that into a container disk, importing that volume into Openshift, which is using KubeVirt. And now we are running a bootable container inside of a virtual machine on Openshift. So let's see just how that looks. And I see that the playbook here is done. And the virtual machine console is starting up. And we see that I should be able to log in. Ah. Bootc status, and you see that I've deployed from the image in Quay that we built. And with that, that was everything I had for the demo. Thank you and have a nice day.